My next step being just writing out both equations, and I'll label it like this so we can see it pretty clearly. So for E1, we're gonna plug in columns constant, 8.99 times 10 to the 9th. Now we have our Q as well. So we're gonna do our Q1 is 4, a positive charge, times 10 to the negative 9. That's all gonna be over 0.1 squared. Now for our E2, it's gonna look slightly different. It's gonna be the same exact equation. It's gonna have the columns constant in there. Then for the Q2 charge, it's -5. However, in the electric field equation, Q is in an absolute value bracket thing. So it's just gonna be 5. And that is all gonna be over 1. I'm gonna come right back with the answers for all these. This here is just our y values, and we're just finding just the net components of what EY is. So if the way we want to write it out is just EY equals EY2 plus EY1, and then you get the sum of all forces in the y direction. So it's just going back to like I said, this is just going back to some displacement just with different stuff. So it's just going to look like the sum of all forces in the y direction equals -3.596 times 10 to the third plus 4.495 times 10 to the third. And I'll come back with that final answer. And this is my work, and my final answer here is a positive 0.899 times 10 to the third newtons over columns.